Okay, so what we covered yesterday was how you could figure out what the empirical formula is. And remember, the empirical formula is the simplest ratio that a molecule can exist in. It's not the correct ratio, right? So if we figure out the simplest ratio, how can we actually get to the real ratio? Good question. We got to do one more step. So this is how you convert molecular formulas, empirical formulas into molecular formulas. Remember that one we did yesterday where we got CH2? CH2 is not a thing. Carbon needs 4 lines to it. So this is a WTF molecule. It doesn't exist. Exists empirically, does not exist as a molecular formula. So how do we go about tackling this? Well, maybe you burnt it and you figured out what the ratio is, and then you run it through a mass spectroscopy system and you get the deflection of it relative to carbon. So now you know how much it weighs. You know, well, how much it deflects relative to carbon. So we just have to do some very simple algebra, okay? For every carbon, there are 2 hydrogens. Does everybody kind of agree with that? So what we can do is go 1201 grams per mole times N plus 101 grams per mole. That's the molar mass of hydrogen times 2N, and make that all equal to 4209. Once we figure out what N is, guess what? We know the real ratio. Okay, so let's just get rid of, can we just get rid of moles, grams per mole? So that's 1201N, and that's 202N equals 4209 grams per mole. Okay, add those two together. Man, I'm bad with mental math. Okay, we get 1403 N is equal to 4209. We divide both sides by 1403, and we get 4209 divided by 1403. We get 3. So the ratio then is C3H6. And that compound does exist. You probably can draw it. So all I said was you can even get a bigger one. Let's say we had like a whole bunch of stuff like maybe the empirical formula is C3S2O4. Then it would just be C3N S2N O4N, and then you would times these by the molar masses and figure out the ratio, figure out the N. Okay? All right, let's try another one. A compound has the empirical formula CH2O and has a relative molar mass of 150.15. What's the molecular formula? Okay, so we can't actually tackle this one yet because we need to write down our ratio. So we've got CN, H2N, ON, right? One oxygen, 2 hydrogens, 1 carbon. So we'll go 1201 N, that's the molar mass of carbon, plus 101 2N, atomic molar mass of hydrogen, and 16 N, atomic molar mass of oxygen, and then equals 150.15. Okay, so I'm just going to do this in one step, add up all of my N's. Okay, I get 3003N. And that whole thing equals the relative deflection, 150.15. Okay, 150.15 divided by 3003 gives me N is equal to 5. So I go back in and times everything here by 5. C5, H10, O5. Okay, I don't know if that exists, but that's what it is. Okay. All right, so there's one more concept. Sorry, I'm just a little far away. Okay, there's one more concept I'm going to cover, and it's the percentage. Oh, go forward, please. is the percentage by mass of a certain element in a compound. So what is the percentage by mass of something like carbon and methane? So it's pretty easy to do. All you have to do is figure out the ratio of carbon to the entire other substance. So carbon has a molar mass of 1201, right? There's just of carbon, okay? And we're going to put that over 1201 for carbon, the total molar mass, and 4 times 101. Okay, so what do we get there? 1201 is the top. Yes, the bottom is literally the molar mass. 1605. And then we're going to times that by 100. So all we're saying is the carbon in the total substance weighs, it's going to be pretty heavy because hydrogen's really, really light. Okay, I get we'll go to 3 sig figs, 74.8%. Pretty cool. Okay, so that's how you get percentage by mass of a substance in the compound itself. So it's mostly made of carbon. Okay, next one. What's the percentage of mass of hydrogen in NaHCO3? Pretty low. So there's one hydrogen, so 101. All right, and then what you can do just to make your life easier is calculate, instead of going like, there's one sodium, so 22.99 times 1 and blah, blah, blah. Just figure out the molar mass of the whole thing. 2299, plus 101, plus 1201, and then we get 8401. That's the molar mass of the entire substance. Okay, that's probably a faster way to do this. Times that by 100, so 101 divided by 8401, times 100, we get 1.2%. So not very much of the hydrogen is responsible for the weight. Okay, that is lesson 2 of empirical chemistry.